Hey everyone, so today we'll be talking about Pygame in Python, that is basically used for working with video games, creating video games in Python. But before that, we need some prerequisites that are your knowledge in Python. You should already be acquainted with some basic idea of Python. Then you should have Python installed in your system. If not, I'll just guide you through some quick steps. We'd be working on VS Code. So we'd need VS Code, we'd need Python installed in your systems, plus we'd need the Pygame module. So let's quickly see how we can get all these. And you'll find this download python.org. It's the official website. If you need any documentation related help from Python about Python, then you can search it over here. So you're gonna click on this link, okay, and you can easily download it. Like, it starts right away, and then you have to set the environment variable, which is not a big deal. And for downloading VS Code, you write download VS Code, and there we are. We download VS Code and it should start right away. You just have to wait for some time. Okay, so as you launch VS Code, this is what we get. This is the interface that we see. This is where you open all the folders. This is where you search for your files, and this is where you download your extensions. So since if we are working, maybe you are working with Python for the first time, you have downloaded it for the first time, you have to write Python and download the extension so that you can work with VS Code and Python. Here I am getting this disable and uninstall icons because I've already installed this extension, but if you have not, you'll get an install button over here. So you click on it, and then once it is installed, you'll get a reload button, so you reload it so that you can work with Python on VS Code. So I need to open a folder, and so I open a folder here, which I've named as Python. It's an empty folder I made on the desktop, a very simple one. It contains nothing, and it'll get opened as soon as I click on this. And then we will add a new file. This is how we add a new file. We'll name it first .py. You always need to give extensions. .py is the extension for a Python file. You tell VS Code that you're going to work with Python. You might say that you only have Python extensions, so why do we need to mention .py? But maybe when you learn a lot of languages, you have a lot of extensions. Then it would be a confusion for VS Code what file you're working with. So you need to mention the extension, you need to mention .py. For HTML we do .html. So yeah, let's try to print something. We'll print hello. Let's see, let's run this. Let's see if it runs. And we have our hello printed. Cool. This is what we needed. Now we'll install Pygame. So to install Pygame, you need to write on the command prompt on the terminal that okay, please open command prompt while you're doing this. Do not work on PowerShell. Yes, you should see something like this, and you'll write pip install Pygame. I already have Pygame, so I don't need to install it separately, but just to be on the safer side, just run this command and see that you have Pygame, or install this. This is the only command that you need to run. There are no extra commands that you need to run for downloading Pygame. It's really simple. Now we'll move on to the coding and introduction part of Pygame. So let's get to it. So I have made this little code for you so that you can understand how we work with Pygame. First of all, the introduction of Pygame. It is a Python module that is for creating video games. You can create a number of video games like the snake game, tic-tac-toe. You can make any space shooter game. You can visualize moving objects. You can draw shapes, and you can do a lot of stuff with Pygame. It has a lot of functions, a lot of methods. It works really efficiently with the latest version of Python. What I have done is that I have divided any Pygame code into 3 basic steps. That is importing Pygame, initializing Pygame, it was 1, setting up the screen on which we would see the output, and running the game loop. Okay, so you might not get the idea of setting up the screen and the game loop. We'll get to it slowly. So first of all, importing a module. This is how you do it in Python. You write import and then you write the name of the module that you want to import. Then we have this initialization part, that is pygame.init. Don't worry about from pygame.locals. It's another method of Pygame. We'll talk about it later. Then we write pygame.init. We always write it because we want to call all the functionalities of Pygame and want to work with it. Like display is one of them, .display. We then set up a screen, the second point. This is how we do it. We call on to Pygame. We get into display. This is one module inside Pygame. And then we write .set mode to set the screen. And this is the size of the screen that we give, the x-axis and the y-axis. Okay. So then we have the game loop, which is an infinite loop, and inside it we are first writing screen.fill with a color code. I hope you get that this is an RGB color code. If you don't worry, I'll refer you to a website and you can read about it there, and we talk about the RGB colors more in the next video. And this fill is a method that helps you color the background with this color. Okay, then comes the for loop for the event of the Pygame, and we'll talk about this in some time when we'd get some more knowledge about what is happening in this code. But for right now, all that you just need to know is there are 3 basic steps: the importing, then initializing, setting up the screen, and having a game loop. Okay, and please set up yourself with Python and VS Code. If you don't already have them, then install Pygame, and we'll be talking about a lot more terminologies in Pygame, and there's a lot to learn. Pygame is a very vast module, and you'll get a really good hands-on to it if you follow this tutorial. Just to get an example, let's run this. This is very simple code in Pygame. This is a very simple code in Pygame. I have done literally nothing in this. It's just the display of a screen, just so you do not get like overwhelmed with what is happening. I'll just run this and see what we get. We get a window that is red in color that we specified 200,0,0, and that's all. That's we get. Okay, we click cross, and we can change the size of this window. Let's see. Let's do this 200 and 200. Let's run this now. Let's see what we get. We get a smaller window size. You can even see that the maximize icon has been disabled because we cannot maximize this. We have already specified the size of the screen and it is 200 by 200. So yes, this was a live demo of Pygame, and we'd be doing a lot more advanced stuff than just displaying the screen with a color, with a basic color. We'd be seeing different the screen changing colors and a lot more, making video games and various stuff in Pygame. Till then, get your systems ready for working with Python. Hey everyone, in today's video we would be discussing some basic terms and methods in Pygame module. Also we'll see some related examples. So let's get started. First up we have initialization of the module. So we write import Pygame and then we initialize it by writing pygame.init. We can also initialize a module in Pygame separately. Like here I've written pygame.display.init. We have separately called upon display. We have separately initialized display module. But if we do this, you would not be able to work with other submodules. You have to initialize them separately then. So that would be a little bit tedious. Rather, we do this pygame.init. This initializes all the subclasses and submodules of Pygame. Okay. Now to quit or uninitialize any module, we use .quit method. We have already used it in a game loop. Once we are done with working with Pygame, we do this pygame.quit, and this is how it is uninitialized and we can move out of Pygame. Okay. Then I hope you remember in the first video I told you that any Pygame code would be divided into 3 parts, and that is initializing, setting up the screen, and the game loop then. So the second part we have, that is setting up the screen. So the setting up of screen is done using the display module. Okay, so please listen carefully. Display module creates a new surface object which helps us visualize whatever we have created. A text, a drawing, or an image. It can be anything. Okay. And display method helps us visualize what we have created on the screen. We set using the set mode. Okay. So this 600,600 is the size of the screen. Okay. Last time also we saw this. And it is not just confined to setting up the screen, giving sizes. It has methods like getInit. GetInit gives us a boolean response, returns a boolean response which tells us if the display module is initialized or not. It has quit, of course. It has init to initialize, and it has getSurface method which gives reference to the current window. Okay, so if you don't get this right now, it's all right, because we have not seen any example related. Once we see that, you'd be a little bit clear with it. We have flip and update. There's a difference between flip and update, although they are a little bit similar. What does flip do? It updates the entire window. Okay, but update updates only portions of the window. Okay, which are specified, and whereas flip doesn't do it. So you can say that update is an optimized version of flip. So we usually use update so that less memory is used. Okay. Then we have fill method, which fills up the screen with some color. Okay. So we are done with the second step. Let's move on to the third part. That would be rect. Like I would discuss the rect module. The rect class in Pygame is used to manipulate rectangular surfaces and store those objects. We can make copies of those objects, move them across the screen, and do a lot of things to manipulate them, edit them. Okay, we always use rect if we want to work with something that requires another surface or layer, while writing a text, while working with an image. For example, here we are working with an image. Okay, I have loaded the image. Okay, don't worry, this is another subclass. Image is another subclass in Pygame, and I have loaded it. Okay, simple. And then what I have done is I have made another variable which is been declared a rect class object. Okay, ball.getRect. This is how I have declared it as a rect class object, and what it does is it loads this image on a rectangular surface. Okay, so that we can view it on the screen. Fine. So this is one functionality of rect class. Okay, we can even copy this ball object or ball rect, and use it otherwise. We can move it in place, we can change its size by using inflate, we can update its positions, we can change where it is located on the screen, we can clip it, we can crop it, we can resize it, and much more. Rect involves much more functionalities, but these are some basic ones, so which we would require right now. Okay, so yeah, let's move on to the very important part of Pygame code, that is the gaming loop. Okay, and the gaming loop involves events. Every action in Pygame is named through a queue. Okay, a queue is a list which follows first in and first out principle. I don't know if you know about queue or not. It's a data structure, and it follows first in and first out principle, and it's just a simple list where insertion and deletion are done from different ends. Okay, so just treat it like a list, and all the events are stored into a queue. Okay, so every time we call if pygame.event, an action or an event from the queue is popped out and been carried out. Okay, it has been handled. The instructions are been carried out, so that we do not face any loss of event, as the queue might get filled over time. Okay, and following this, an event can also be an input from the keyboard. So to deal with keyboard inputs, we have a different subclass, that is key. Okay, so whenever we call this pygame.keyDown and key up, whenever a key is pressed, these are automatically called up. Okay, and this then helps pygame.event to carry out the definite or whatever event is said to be carried out. For example, I have written down a little bit of code for you, which is talking about how key down and key up works. So here I have just written pygame.keyDown because key down and key up are simultaneous processes. As you press a key, first key down is called, and then you release it, then key up is called. Okay, so you don't need to write it like separately, pygame.keyDown or key up. I have just written key down. Okay, and if the event.key, okay, is KA, this is the way of telling that the key pressed is A. Okay, and this is the way of telling that the key pressed is 0. You can have it for all the keys on the keyboard. Okay, so, or else if not something else is pressed, you output a key was pressed. So let's run this and let's see how it works. Run this, and yeah, so now I'd press A, so A was pressed, it outputs A was pressed. I hope you can see it. Okay, then when I press 0, it shows 0 was pressed. If I press E, a key was pressed because I did not mention anything for E. Okay, So yeah, let's stop this and let's go back to our initial page. This is how we work with keys, and keys have a lot of other methods, like get focused is there if we to check if we are receiving keyboard inputs properly from the system. We have get pressed, like to get the state of all the keyboard buttons. Then we have name. Each of these keys have an identifier, so we get that identifier from this. We get the key code. We can get the key code from the name. This takes an argument, and from the name we can get the identifier. Okay, and so we have other methods also. We'd see them once we use them in further examples. Okay, so coming back to the game code, that was we had initialized the ball image, and then we are working with getting it on the rect class. Okay, we have got it on a rect class object, and I have mentioned the speed, which is 1,1. It works as an argument of rect class method move. Okay, so what I've done is I've given speed as an argument, so it shows that the x-axis, with respect to the x-axis, the object would be moving 1 units, and with y-axis it would be also moving 1. Okay, so rectangle would always have on a plane, it would always have 4 points: the left, right, top and bottom. I hope you can imagine it. And when the left point is less than 0, the speed is the 0th coordinate, like this 1, is changed to -1, because we need to oppose the motion now. Okay, or even when this happens when it's to the extreme right, like it is more than the size of the screen. Similarly, for top and bottom, we are changing the y-axis. Okay, motion of the y-axis, and we will fill the screen with some color that is white right now, and we'll do blit, which is loading the ball object, ball variable, the image on the ball rect. Okay, and then we are displaying it and updating the complete thing. Okay, complete screen. Let's see how this works. If we, this is a random motion, if we make 0,1, so it should only move along the y-axis. Let's see if it does so. Yeah, it is moving along the y-axis. Okay, it's not traveling anymore. And what if we make this happen? It should just move along the y-axis, but with more speed. Yeah, it does. Okay, so that's pretty much it. So next up we have some more definitions or more subclasses. The first one is font. We'd be discussing these in very brief because we'd be working with them further, and we'd be discussing them more deeply in the next upcoming videos. We have font. When we'd be working with text, getting a text on the screen, we'd work with font. We can like see what the default font is, what all fonts are there. We can create a new object from a file. We can edit the text, the style of the text. We can style it. We can make it bold, we can make it italic, we can underline it, we can see what the size is, we can see the ascent and descent of the text, and we can do a lot more. Then when we'd be working with images, we'd be using this image class and image module, and we can load and unload an image, we can change its format, we can save the image, we can crop it, Then we have time. We can keep a track of for how long the program has been running. We can change the frame rates. Then we have music module to work with audios, and we can rewind, we can stop, we can play the audio, and we have even the draw module to draw shapes like circles, polygons. We can even draw a line and curves. And so this is pretty much about the very basic and startup things and the startup modules that are available in Pygame. Hey everyone! In the last video we discussed about some Pygame modules in brief. Now it's time we put that to use. We would try displaying some text on Pygame window. Let's get started. I have initialized Pygame as usual, set up the screen, and then is the new part. I have used font module by Pygame. We have used sysfont then, which takes in attributes like the font style, size of font, mentioning about the italics and bolds. It is an option here if you are mentioning about italics and bolds, but you have to mention the font style and the size of font, otherwise you'll get an error from sysfont. If you do not mention about the italics and bolds, they are false by default. We have a lot of system fonts. Let's take a look at them. If you run this piece of code, pygame.font.get fonts, you will get a list of all the fonts that are available in the system. Here it is. You can use any of these fonts to design your text. Firstly, I'll just walk you through the basic code. After that, we'll add some more functionalities. So after creating a font object, I declared a text variable which would create a new surface with given text rendered on it. I hope you get this. It would create a new surface with given text rendered on it. Then we call the rect class object to see the text on Pygame window. Last time we discussed the rect class in detail. I hope you understand what is happening over here. Then is the infinite loop. You will fill the screen with some random color. Use lit from surface class to get the text and text rect on the window. That is to draw text on text rect. Okay. After that, we have event in pygame.events, which updates and runs the given command until we quit. Okay. So let's run this and see what we get. So on running this code, this is what we get. We have the text at the extreme left of the screen. But what if I need it in the center of the screen? So let me change a little bit of it and see if I can bring the text in the center. For that, we have text rect.center. So I brought the rectangle surface to the center by using this method, and I have specified the coordinates as the center of the screen. The size of the screen is 500 by 500, so I've divided it by 2 and we get to the center. Let's run this now and see what we get. Voila, we have the text at the center. Now let's see what else we can do. We can set a caption to the Pygame window. We use pygame.display.setCaption. We can also underline the text that we have by font.set_underline as true, and let's run it and see what we get. We have an underlined text and we have the caption Pygame text. Cool. This was one program. Now let's try and move this text along the different axes on the window. For that, I have written a little code. First, I have initialized Pygame, then the screen with size 500, 500. Then I have declared the font object with style Times New Roman and size 30. Variable letter is used to render the so created font object. Then I have declared a variable I that decides the speed of the text, how fast the text changes its coordinates. Please note that right now I am moving the word along x-axis only. So entering the game loop now, there is a condition. If I is greater than 500, that is the length of the screen, please see that the length of the screen is 500. When I is greater than 500, I is equal to 0. We make I equal to 0. This means once the text has traversed complete length of the screen, we want to see it appearing from left again. And the time gap between this action is of 5 milliseconds. I have done this using the time module of Pygame. So pygame.time.wait 500 gives a gap of 5 milliseconds between these two actions. Then comes the win.fill. So I have colored the background white with fill. Now comes the tricky part, rather not tricky part, but you would need to visualize it a little. So here in Blit, we have used the font object and rect class object always. But this time I have taken no rect class object, as you can see, but I have given coordinates I comma 0, which shows the origin because I is equal to 0 for right now. So that gives me the origin, the extreme left upper corner of the screen. Once this runs, I is increased by 80. So you must infer that larger I gives more speed, as this is what is giving the difference between two consecutive spots of the text. Okay. Please try to visualize this. And again, there is a wait of 5 milliseconds after we run this event loop between the appearance of the text at two consecutive positions. There is a wait of 5 milliseconds. I have given a wait, otherwise we won't be able to visualize the text moving. It would move in a flash. So let's see this running. Let's see what we get and how this text moves across the screen along x-axis. So now let's run this and see how the text moves along the x-axis. Yes, so this is how it moves along the x-axis. We can also move it along the y-axis. For that, I'd need to interchange these two coordinates. I'd make it 0, I now. So it would move along the left side of the screen. So let's run it and see if it moves along the left side. So yeah, it does run. Okay, cool. You can even think about how we can make this text move along the bottom of the screen or along the right side of the screen. For that, you might need to change the 0 to something else, maybe the size of the screen, the y or the x-axis. So think about it. Hey everyone, this video is going to be about image handling in Pygame. We would load an image, see it scrolling across the screen, rotate it and scale it. And also we would talk about the transform module, which is readily used with images in Pygame. So let's start with normal image loading. I have initialized Pygame, declared the screen, and in the fourth line I have used the load function from image module by Pygame to load the image. It takes one argument, that is the name of the file or path. Let's keep it simple for now, just use the file name. This is the image we would work with. Then is our normal game loop. I have colored the screen white with fill, used Blit to get the image at the provided coordinates. We can also use the rect object, we would do that in a minute. And then there's our regular events loop. So let's run this code and see if the image is loaded on the screen. So yeah, it is up and running. But what if I needed the image at the center of the screen? We would just repeat what we did last time to bring this text at the center. There we had the font object, here we have the image object. We would get it on the rectangle by declaring a rect object and assign its center the center coordinates of the screen. Let's run this now, see if our image is at the center. So yeah, we have our image at the center of the screen. Cool. What if I want to move this image across the screen? For that, we would repeat exactly what we did for scrolling the text. You can see here I have taken the speed determining I variable, put up a condition, given a wait of 5 milliseconds, incremented I by 80. It's exactly the same. It's just that last time we had text object, now we have image object. So let's see how it moves. Here, you can see the picture moving across the x-axis. You can also try it moving across the extreme left. You can try moving it in the bottom, along the bottom, and along the right side too, just like we did for the text. Now let's try to rotate a still picture. For this, we would use the transform module. As you can see, I have loaded the image. In the 7th line, then I have used rotate function by transform. It takes two arguments, the object you want to rotate and the angle by which you want to rotate. The positive angles rotate anti-clockwise, and please note the angles are in degrees. And after that, we have our simple game loop with no new things. You will fill a color, get the image object on the given position, then run the events loop. So without wasting any time, let's run it and see if the image is rotated. Yeah, we have our image rotated clockwise by 90 degrees since I gave an argument of minus 90. Cool. Now let's try to scale the same image. For that, we would use the scale function by transform. Scaling is just resizing the surface to a new size. The second argument here is of the new size that you want for the image. And then it's our normal game loop. So let's run it and see if we have a new sized image. Yes, we do have a new sized image. The original image squeezes into the size we have provided. That is 200 by 200. In the last two programs, we used transform module. This module has some more functionalities. Let's look at them. So I have loaded an image. It's the same program as of the first one. And use the flip function now by transform. So it takes in three arguments, the surface you want to flip and the axis about which you want to flip. I have flipped it about x-axis as the second argument is true and the third one is false. If I run it, my picture is flipped about x-axis. You can do this for y-axis as well. Then you can even set both of the arguments as true. Then the image would be flipped about both the axes. Next up, we have the roto zoom, which is a combination of rotation and zooming in the image. Of course, the function itself, the name of the function itself explains it. It takes three arguments as well, the surface you want to work with, then the angle of rotation, and then the zoom in factor, which takes a float data type. So you can give in arguments like 1.5, 2.5, and 2.25, etc. You can give in a float data type. It is not just confined to integers. Fine. Let's run it and see what we get. So we have our picture zoomed in by 1.5 and it is even rotated by 90 degrees. You can even rotate it by 180 degrees, not a problem, or by 360. Then you'd get the same image again. Now, if you want a picture double the original size, you can use the scale 2x function. If you're using this function, you do not need to mention the zoom in factor. It's automatically 2. We get a picture which is double the size of its original size. So let's run it and see if we have what we are expecting. So yeah, the image is double the size of its original one. Transform also has this average color function which gives you the average color of the mentioned surface. Now if I print this, for the current image, it comes out to be this color. There's a color, this is an RGB format. So yeah, this is one color that we get. It is the average color of the given image. So in this video, we worked with the image and transform module. Next time, we would work with the music module in Pygame. Hope this video helped you. Thank you. Hey everyone. So today we'd be talking about the music and mixer module in Pygame. They go very hand in hand. The mixer module has many modules like music, sound, channel. Today we'd be talking about only the music module. I could have used the sound module as well, but the music module is more versatile. They eventually turn out to be similar, although the way they work is different. So what the mixer module does is, it helps to control playback of the streamed music. We won't do anything tedious today. We would just learn some functions by music module and write a code to understand how they work. So the first function we have in music module is load. As we had load in image module, just like that, here the load function loads the music file and prepares it for playing. It doesn't play the music. Please note, it doesn't play the music. If music is already playing, the load function would stop playing it and restart everything. Then next, we have the unload function to unload the currently loaded music file and free up space and variable. Then we have the play function, which is used to play the music once loaded. So it takes in 3 arguments. They're not mandatory, but you can give at most 3 arguments. So the first one is how many times you want to repeat the music, which is called as loop. It should be an integer. Then we have start position, which should be a float, from where the music should start. That's what it mentions. Then we have fade underscore ms, the time for which the music should fade to volume 0 in milliseconds. Please be careful while giving the arguments in Pygame, as there are many units of time in Pygame. Then we have the rewind function, which plays the audio file from the beginning. It's very simple. If audio is paused, it remains paused. If unpaused, the music starts from the beginning. Now we have the stop function, which stops the music. Please note that stop and unload are not the same. Then we have the pause function to temporarily stop the music. Then we have the unpause function to resume the music after it is paused. Then we have this fade out function. It takes time argument for which music should fade out in milliseconds. Cool. Then we have some methods like the set volume, get busy, set position, get position. Let's discuss them one by one. We have the set volume method, which is used to set the volume of the audio. We can know the current volume of the audio by checking the get volume. We can know if the player is busy or not by using the get busy method. It returns a boolean, which is true when music is playing. Then we have the set position method to set the point from which playback should start playing. Then we have get position to get the time for how long the music is being playing. Then we have this queue function to enqueue a song to the current one. Once the current song is done playing, the queue function would play the next song automatically. We can only enqueue one song at a time. So I don't want to write pygame.mixer.music over and over again. So what I did is I wrote from Pygame import mixer. I initialized the mixer module, loaded the song, then I used the play function to play it. Now we would see other functions later. Let's do the basic music streaming first. Then I have printed the boolean get busy to check whether the player is busy or playing something or not. Then I have a loop. A loop is not necessary because we don't have the screen displaying something or not here. We don't have any events. Just to make the program more functional, like an audio player, I have done this. I have taken an input, like for P, pause, U to unpause, R to rewind, S to exit. Then I have these conditions to pause, unpause, rewind and exit according to the input. So if I run it now, you would hear an audio and it's the song.mp3. It's right here in the Python folder. So let's run this code and see if we hear an audio. So I press P and I get the answer as false, as the player is no more streaming and it's no longer busy as I have paused the audio. If I unpause it, you'll see that the getBusy function returns true. So I've stopped the function and it returns false. The getBusy method returns false as the player is no longer playing the music. Now let's try using this getVolume method to get the current volume of the audio. Then I'd be setting the volume to 0.8 by using setVolume method and check it again if the volume was set properly. Now let's run this. So we have the volume to 0.9, which is almost 1. And then we have set the volume to 0.8, so the volume comes out to be 0.8. So yeah, things are working as we want it to be. Now let's try getting the position for how long the audio has been playing. So the audio has been playing from 1 milliseconds. The output is 1 millisecond. If more functions are being called out, the time would increase. Now let's try doing the fade out function. So I have written mixer.music.fadeout and written 10,000 in the argument. So I have given the argument of 10 seconds. That is, after 10 seconds, the music should fade away and stop. Since 1 second has 1000 milliseconds, so I've multiplied 10 by 1000. So let's check if the music fades away after 10 seconds. So yeah, the music did fade away after 10 seconds. And if I check for unpause now, or let me check for rewind, if I check rewind now, it comes out to be false because the fade out function completely stops the audio player and hence the player is no longer busy. Now let's try the set position function. I have given the argument as 120 seconds. So I want the music to start from 2 minutes, from the position 2 minutes. Let's see if the music starts midway. Let me run this. So yeah, the music starts midway, that is from 2 minutes. Now let's use the queue function. I'd be writing mixer.music.queue and I've mentioned this next song.mp3. It's also in the Python folder. You can see it over here. I don't want to wait for like 2 minutes to listen to the entire song. Then I'd check if the song is queued and it has been played automatically. So I'd set position as 170 seconds so that the song starts from the position 170 seconds so that I can skip the song. Okay, so let me play this and see if the song has been queued. So yeah, the song gets unqueued and it has been automatically played without any indication. This was all about the music module. I hope you understood what all was explained. Thank you. Hey everyone. So till now we have talked about the font, music and image module in Pygame. It's time we get a little bit inclined towards the video game creation part of Pygame. In this video we won't be creating a video game, but yeah, we would be doing something related. we would try to see a snowfall. We would try to create our own snowfall on the Pygame screen. So if I'm talking about snow falling, then it should make sense to you that we would do something related to the moving text or moving image, but along the y-axis. And if it makes sense to you, if you're able to think about that, then yeah, you're on the right path and you have actually understood what has happened till now. And a little bit prerequisite for this video would be the knowledge of the random module. If you don't know about it, it's all right. I'd be telling you about random module. Moreover, we would just be using a function from random module. I would need random module. Just think about it. Why would I need random module? Because I want snow on random spots of the screen. Okay, so that's why I'd be using the random module, so that I can have random coordinates. All right. So let's get to the code right away. It's going to be very easy. So first we have the basic 3 steps. I hope you remember. The first step is initializing Pygame. I have done so. Then I have imported random module just so I can take random spots, random coordinates. Then I have the step 2, setting up the screen. Then I have taken up a list, snow. So what I would do is I would append some coordinates in snow, which at which I would need the snow, at which I would draw the circles. Okay, so I have run this for loop. Okay, for range 50, the length of the list would be 50, and then I have picked up a random number. This is what rand range does in random module. It picks up a random number from the given range. And similarly for y coordinate also. And then I'd be appending the list to the snow list. So snow becomes a 2D list just like this. I hope you get it. And so we have a list that has some random coordinates. Okay. Then I have set up this clock object from the time module so that I can work with the frame rate later. You'd get the purpose of this later. I'll tell you later at the end of the program. Now is our third step, the game loop. So then we have our events loop as usual. I have filled the screen with white color. You can also take black color and white color snow, doesn't matter. Now is the main part. For ice in range length snow. Now we would be traversing each element of snow and draw a circle at that coordinate. Okay, so for that I have written pygame.draw. I have used the draw module and used the the circle function from draw. So this is the screen, the surface on which we want to draw. Then I've mentioned the color. I want blue circles, and then the coordinate would be given by snow, ice. Okay, and the radius would be 2 pixels. Since I want the snow to fall along y-axis, I'd be increasing the y-axis. You can see like the y-axis would be given by the ice element's first element. Okay, this might be a little jumbling. How do you access a 2D list? You go to the first number, like I go to the iced element, and then go to the first element inside that list. So this becomes the y coordinate of the random point. Okay, cool. So I'd be increasing that by 1 each time. Okay, because I want the next spot to be just below it. I do not change the x-axis, but I change the y-axis because I want the snow to fall down. Now there is this corner case that if the coordinate now becomes greater than the screen size, which is 400 right now, then what I'd do is I'd pick any random number. Again, I'd completely change the coordinate. I'd pick any random number from -50 to -10 because I want the snow to fall from the top and not from any random point and not from in between. So that's why I've taken this negative range, and I'd reassign the value of the x coordinate also, since it's ice and 0 in square brackets. Then I update the display. You can also use flip here, not a problem. Then I have used this clock object and use the tick function so that I can set up the frame rate. By default it's 0. If you do not mention this, the snow would fall in a flash, like it would look like it's running, the snow is running. It won't make any sense. So the larger the frame rate is, the slower is the snowfall. Okay, so let's check it out how this works. So we have our snow falling very properly, just randomly from anywhere, as snowfall is. You can also take up different colors, like let me change the color here. Let me do black and make this circle of white color. So let's run this. Yeah, this also looks nice. You can try either one. You can even have any combination of colors. So that's pretty much it about this video. Hope you understood the program. We'll do more in the next videos, in the upcoming videos. Thank you. Hey everyone! In the last video, we made our own snowfall and tried to use the basic concepts to make something better. This time, we would again move an object around, but the movement would be user-controlled. Last time, if you remember, it was pre-programmed. So if I say user-controlled, that means we would take the keyboard inputs and move our figure around the screen according to those inputs. I hope you remember the key module we talked about in the second video. Now it's time we put that to use. Let's get to the code right away. We would go stepwise, initializing Pygame, setting up a screen. The screen size, I have taken it to be 500 by 500. You can take any screen size, not a problem. I have also set up a caption, which is moving the given object. Then we have declared the initial position of the object as x, y. It is 100, 100. It is the position on screen. We would find our object right after we run the code. Cool. Then we have to set up the speed. The speed by which the object would move. The speed by which we want the object to move. So it is set up to 3, which means the object should be displayed by 3 units along the given axis on pressing the respective key once. Then we have the size of the object. I have tried to make a man figure with a circle and rectangle. It's my object. That's what I want to move around. So this width and height is for that rectangle. If you didn't understand, you would get it when I draw the figure. Okay. So then we have our game loop, the regular one. I have given a time delay of 10 milliseconds so that object doesn't run and we can observe the defined speed properly. Delay is used to pause the program, and so we have a refreshed screen after that. Then we have our events loop, used for handling events, and quit the program if asked to do so. Then I have taken a key variable that would contain a list or sequence of the status of all the keys on the keyboard. Key is a list of booleans that can be accessed like this. We just access it like a normal list, but the indexing is done using the key constants. So this is done with the help of get_pressed method. The one key that is pressed, its state is true. Other keys have a false state. So I have these 4 conditions. My object can move around in only 4 directions: left, right, up, and down. So accordingly, I have these 4 conditions. When I press the left arrow key, I will reduce the speed units from current x coordinate. When the right arrow key is pressed, I will increment the x coordinate by speed units. And similarly, for going up and down, I decrease or increase the y coordinate respectively. I would print what arrow key I have pressed, or so that it is easy for you to understand and there is no confusion. This x greater than 0 and x less than 500 minus width, then y greater than 0, y less than 500 minus height. These all conditions are used to keep the object within the screen so that the object doesn't run out of the screen. So that should be easy to understand. Now, this is the code for making my man figure. So it's just a circle on a rectangle. So you use the rect function in draw to draw a rectangle. Here x, y are the coordinates or position of the rectangle, and width and height are for the size. Then there is a circle. Now to place the circle right on top middle of the rectangle, I found the mid of the width and also reduced y-axis by 5 so that there is just an overlap of 2 units between the rectangle and the circle. I hope you understand the height of the rectangle was 7, and if I reduce the y-axis, this 7 by 5, there is an overlap of only 2 units. Hope you can visualize it. Then we update the program and let's run it. Okay, so this is what we get when we run this code. We find our object at the initialized position. It's 100, 100. It's at coordinates 100, 100. Now, if I press the right arrow key, I should see right arrow key printed, and the object should also move right. Cool. Let's do it once. The object moved right, and right arrow key was also printed. Let me press the down arrow key. So it should move down. It moved down. The object moved down. Now let's try for left arrow key. We have left arrow key printed and it also moved left. Let me press left arrow key again. So yeah, it's going left. Again, I'm gonna press left arrow key. Yeah. So let me take it to the origin. Cool. In the next video, we would try to make the snake game. We would try to create that on our own, a video game, a live working video game. For that, this moving object program would be very important. If you understood this moving object program, then the snake game program would be very easy for you. And from the next video onwards, we would put to use all that we have learned till now, all the basics that we have learned till now. And things are going to be very interesting. So from now on, we would look at the real application of Pygame module, which is video game creation. Things are going to be very fun and easy. I hope you're understanding what all I have explained till now, everything that I have taught you. Thank you. Hey everyone, in this video we will make our first video game, the snake game. If you haven't heard of it, then it's a game where there's a snake. You move it around the screen in order to eat the food. You should not bite yourself while going in several directions, and also you should not collide with the boundaries. Simple. Let us think through how we would carry out all this and try to write an algorithm. So I have this list of steps that we would need to carry out to make the snake game. Okay, cool. Our snake must have an initial position. You get that, right? It should have a start position. So let's define that. It should also have a body. It can be done using a list, basically. It would be a few rectangles at consecutive coordinates. I hope you can imagine that. The body of the snake would be nothing but a few rectangles arranged in a line, one after the other. We would also define the food position, which would be randomly picked every time the snake eats the food. Cool. So for random picking of the spot, we would also need the random module. Then we would also keep track of the score and increase the size of the snake whenever it eats the food. Fine. We would define a game over function. Whenever the snake touches the boundaries or bites itself, we would show game over on the screen. Also, we would need to handle the movements of the snake by key inputs. We would use the key module here. Cool. So these are the 7 parts we would need to build, and then we would put them together to make the snake game work. So first we will initialize the snake's initial position. Also let me define the rate at which the snake moves, the refresh rate. Fine. Then this is the clock object that we would use for the frame rate. Now according to the second point of the algorithm, let the snake have a body. We would need a body for the snake. Basically, the snake's body would be consecutively arranged rectangles on the same line, as I said before. I have initially taken 2 rectangles, you can take more. A smaller initial size would help you notice the increase in size of the snake after it eats the food. For the food, we have this random coordinates taken. Then they are multiplied by 10 because we want no overlapping with the edges so that the snake doesn't go very close to the edges. As we're going to set a condition of the game over if the snake touches the edges. Cool. I have taken this food boolean so that I can decide when to increase the size of the snake. You will understand this when we make use of it. And then the score variable is set to 0. Now I have defined a function for displaying the score on screen, just like we displayed text on screen. Created a font, rendered it, used rect to get the text on surface, then used split. This was just getting the text, but the main part is in the game loop. That is incrementing the score every time the snake eats the food. After this, I have the game over function. I have defined the game over function. This 2 is just for getting the text in the mid screen once the game is over. Once the game over conditions are met. They are also defined in the game loop. Cool. This time.sleep is used to pause the program for 2 seconds and quit automatically once the game is over. According to the next step in the algo, we need to handle movements of the snake. For that, I have taken 2 variables, dir, which decides what direction to move in presently. Let it have an initial direction, and dir underscore next, which keeps the track of the input given. Cool. Now we have the game loop, the events loop. We saw the little program of the key module in the second video, for example. That events loop is pretty similar to this one. I have set the variable next underscore dir as the pressed arrow key. So when I press up, the next dir becomes up, and similarly for left it becomes left. And now I have 2 sets of conditions. Now this set of condition updates the current direction if the current one isn't a complementary arrow key. Please understand. This means if the arrow key pressed is down while the snake is going up, no changes will occur, as right now while traveling along the y-axis, the only next possible move can be in the x directions. Same with the rest of the directions, like if you're traveling in the x direction, okay, in the x-axis, you cannot reverse your direction. Cool. And this condition now is for moving the snake just as we moved the object in the last video. Depending upon the key pressed, the coordinate of the snake's position is changed. Then we would try to increase the length of the snake every time it eats the food. So I would insert every coordinate the snake travels through and pop all except the time when the food and snake's coordinates overlap. Okay, I hope you got that. This time I would change food to false so that I can pick a new spot for drawing the food. Once I have done that, then again I set food to true. Also, when snake and food coordinates overlap, the snake eats the food, I will increase the score. Great. We are almost done here. All I am left with is drawing my figures and setting up the game over conditions. Let me draw the snake. It is quite obvious we would repeatedly draw the rectangles using a for loop, and this is to draw the food. Now there are 3 game over conditions. Touching boundaries along x-axis, that is going beyond 0 to 600 minus 10. I have written 600 minus 10 so that you can understand that it is the size of the screen minus the size of one block of the snake's body. Okay. Similarly for the y-axis, it's the second condition. And the third condition is when snake bites its own body. Okay, it's same like overlapping with the food coordinates here. It's just that we have taken a for loop, and the game over function will be called if the snake's first block overlaps with any of its rest of the body coordinates. Okay, that's why I have started with the first position, not the 0th position of the list. Okay, cool. Now the show score is called all the time. I want to see the score on the screen all the time, and then we have updated it. Use the dot update and use the tick to set the frame rate. Cool. Let's run this program and check if everything works fine. What all we need to check is if the snake moves freely, then if the fruit is respotted once eaten at a random spot. Also, we would check that the game over conditions are working fine. We would also check that the snake's size increases every time it eats the food. So let's run this and check out these 4 or 5 conditions. Cool. So now if I run this, I can see my snake moving in several directions, eating the food is getting respotted. Cool. And yeah, the score is also getting updated. And let me see if it gets bumped into a wall, the game should be over. Before that, you can see that the snake is longer in size than it was before. Cool. So let me bump it into a one wall. Yeah, the game is over. Cool. And the screen also went away after my game was over. So this game can be more enhanced. You can print why the game was over, or you can put in some music when the game is over using the mixer module. Make a different function and call it in the game over function. This was the very basic snake game made by Pygame. Thank you. Hey everyone, in the last video we made the snake game. It comprised of various modules by Pygame. This time we would make the tic-tac-toe. It would be a little bit more complex than the snake game, but don't worry, if you are clear with the basic modules of Pygame, you won't have a problem dealing with this. Let me discuss what all functionalities we need to put in to make this tic-tac-toe. So you need to draw a board, right? You know tic-tac-toe is played on a 3x3 grid. So for that, you need to draw that board. You also need to get the images loaded. What images I'm talking about X and O symbols. We won't be sketching anything manually. We would just be rendering the images of X and O symbols at the place we want to. We would also need to print the results on the screen. We would also need to check which row or column has similar symbols so that we can strike that out and declare a win. Okay, we would also need to declare a function where we can get the coordinates of our mouse click and put our picture over there, paste our picture over there. So to get all this, I have defined 5 functions and we would put them together to make this tic-tac-toe. Cool. So what the 5 functions are, we would draw the board, 1. We would get the results printed, 2. We would check the winning cases. We would check all the rows and columns if there is a win. We would also need to get the coordinates of the mouse click. We would use the mouse module, that's a new thing for you. And we would put the pictures at these coordinates. That would be the image rendering part. Cool. Let's get to the code. So I'd be importing Pygame, initializing it. Then I'd be declaring some basic variables. Okay, so don't worry if you don't understand their purpose. You would understand it once we start manipulating them in the code further. Cool. So I have this XO. It would hold the current value of the symbol, whatever symbol we are working on, whose ever turn it is. Okay, then we have winner. It would store the winner, X or O, and declare and print the message. Then we have draw. It is initialized to none right now, but if it is a draw, it would be true. Okay, it's a boolean basically. Then I have this board. It's initialized as a 2D matrix with no values, none values, and it's a matrix basically of 3 cross 3, of size 3 cross 3. Then we have this clock object, and then I have the screen, then I have set the caption, then I have rendered the images. I have this in the tic-tac-toe file, so accordingly I have mentioned the path. Okay. Then I have scaled the images because I want them in a block. Okay, we have these nine blocks, and I want it in the same shape. Okay, I want it in the same size basically of the block. Okay, then we have our first function, the draw grid. We would be drawing the board with lines. I have filled the screen with some color. Then I have drawn the lines. I would need two vertical and two horizontal lines. I hope you can get that because I need to draw 3 parts. Okay, so I'd be drawing the vertical lines first. So I have used the line function by draw module. The screen is the surface I would need to make this lines on. Then I have given the color of the line. Then I have the start and the end positions. Okay, so the start and end positions need to be visualized by you, just like you would visualize a point on a coordinate axis. Okay, so 400 by 3 comma 0 would be a point on the x-axis, right? So 400 by 3, why 400 by 3? It's because I am making 3 parts of the complete board, and what is the length of my screen? That is 400, and by 3 gives you the one third part of it. Okay, similarly 400 by 3 comma 400 gives you the last point, okay, on the x-axis, but at the bottom. Cool. And 6 is the size of the line. Similarly, for the second line, I have multiplied the same thing by 2, so that is just an interval ahead of the previous line. Okay, hope that makes sense to you. Then to draw the horizontal lines, I have just flipped the coordinates, because now I'd be taking coordinates on the y-axis, just like I took coordinates on the x-axis to draw the vertical line. I take points on the y-axis to draw the horizontal lines. Okay, it should not be problematic at all if you can visualize a coordinate plane. Cool. Then I'd be defining the result function just for printing the result on the screen. So I have made the draw and winner variables global so that I can work with the same variables throughout. Now if I have a winner, X or O, a message would be printed. Like I would have a message that would be a string, and that would be the winner's name and 1. Okay, similarly if draw is true, my message would be game draw. Now just like we would display a simple text on the screen, I have done that. I want my message to be rendered on the screen, to be displayed on the screen. It's the same code that we used in the display text. Nothing is different. Then I have this win cases function to check if all the symbols along a row or column are same. Okay, we would check it 9 times right after every image is rendered. Okay. Now, just as I said, we would check along all the rows, the columns, and the diagonals. So to check along a row, we would run a for loop so that we can change the value of the row 0, 1, and 2. And we would check if all the symbols along that row are same. That's what the if condition does. And the element we are checking should not be none. Okay. If it's not so and all the symbols are same, then we would assign the winner to be that element. Okay, and we would draw a line across that row. How we would do that? We would use the line function from the draw module, and since we want to draw a horizontal line, please know that we would need to take coordinates of the y-axis. So we have the start point to be 0, row plus 1 into 400 by 3 minus 400 by 6. Now row plus 1 is because the indexing starts from 0 and we cannot take 0 to be something. And I have subtracted it by 400 with 400 by 6 because I want the line to be the half of it, okay, half of the block. And so is the case with the endpoint, okay. And then I'd call to the result function because I wanna, if there is a winner, then I want to call the result function so that the result is printed and no further game is being played, okay. Similarly for the column, I would have a loop to traverse through all the columns, and I'd check accordingly if along a column the symbols are same. Then I'd assign that value, that element, to the winner variable, and then I'd draw the line along that column. Since I want a vertical line now, I would be taking points on the x coordinate, okay, x-axis, sorry. And this start and end point again should make sense to you. Just as we did above, I want the line to be at the half of the block. Again, there is a factor of 400 by 6 subtracted from that value. Cool. Then again, I'd be calling out to the result because I want the results to be printed if there is a winner, and I'd break this loop. Cool. Then to check along the diagonals, I would have two diagonals. In a matrix, there are two diagonals, the principal diagonal and the other diagonal. The principal diagonal runs from left to right, whereas the other diagonal runs from right to left. And the conditions are very similar. You check along the principal diagonal if the symbols are same. If they are, assign winner that value, that symbol, and draw a line along it, and call on to the result function again to print the result. Similarly for the other diagonal that runs from right to left. Now, if there is a draw, then how would you check that? For all rows, if all is true, that means all the blocks are filled now and the winner is still none, then it's a draw. Okay, the draw boolean is now true, and you'd call on to the result function. What the result function would do is it would check the condition for draw, and the message would become game draw, and the text displayed on the screen would be draw. Cool. Now I have this getImage function which takes in arguments row and column, but you would not understand this until you understand this input to block function. So let's get to the input to block function. What it does is it gives you the position of the coordinates you clicked. So basically it is to find out which block is clicked on board. There are several blocks, and once you have clicked inside that block, you would get the row and column as a result of this function. Cool. Then to get the coordinates of the mouse click, we have this mouse function by Pygame. We have this mouse module by Pygame that has a function getPosition. We get the x and y coordinates of that mouse click, and if the x coordinate is less than 400 by 3, the first vertical line, the first part, then it is column 1. Else if the value of the x coordinate is less than 400 by 3 into 2, that means it's less than the second partition but greater than the first partition, the first vertical line, then it would be column 2. Please note that I have used the else if condition for doing the same thing and not if, because I want to check the second condition only if the first one is not satisfied. And then there's another else if, that is the x coordinate is less than 400, which would be the last column, the third column. Cool. Similarly, for assigning the row, I have checked the y coordinates accordingly. Now if the row and column are assigned some value and that board position is empty, it's none, I would call on to the getImage function. Please see to the indexing part. Row and column are normal numberings. When you're using them for indexing, you need to decrease them by 1. Cool. Now let's check out what the getImage function does. So I'll pass on the row and columns I got from here and use them to get my image rendered at that position. But there is a problem. To render my image, I would use the blit function, but the blit function does not identify the row and column positions, but it identifies the destination coordinates. So we again need to convert this row and column to a position, okay, to a coordinate. These coordinates would be same for all the images, for all the positions clicked. To have a uniformity, I would need to again convert this row and column to a single position. The mouse coordinates would be very random, and I don't want my images to be overlapping, and that's why I have to do this. I have to declare another function to get the coordinates from row and column. Okay. So if the row is 1, row number is 1, I want a margin of 30. So the coordinate would be 30, x coordinate would be 30. And similarly, if the column is 1, the position y would be 30. I want a margin of 30. If it is row 2, then I'd be adding 30, the margin of 30 with 400 by 3, because I want the image to be rendered right after the second line with a margin of 30. Okay, 30 units. Cool. And similarly, there are conditions for the third row and the third column. Now I would assign the current symbol stored by XO to the board position that we got from the input to block function. And if XO was X, I would change XO to O because the turn should be changed now to O, and before that I'd render the image at the given position. The X image, and if I have XO as O, then there is this vice versa condition. I'd be pasting O's picture, and now XO would be changed to X. Now, after calling the getImage function in the input to block function, I'd call onto the winCases function, which would check if there is any win in any row or column or along any diagonal. So you should get that after pasting or rendering each image, we would check if there is any win case. Okay. Now we are done with the 5 basic functions, the 5 parts of the tic-tac-toe game. Now we can move on to the main part of the program. I'd be calling the drawGrid function, and then I'll have my game loop. Cool. In the game loop, I have that events loop, where one event is to quit and the other event is to check if there has been any click on the mouse. For that, we have the mouse button down method. If there has been a click on the mouse, then I'd call on to the input to block function. Don't worry, we would just get to the flow of the program if you don't understand how the program is interconnected. And then I would be updating the entire display, and I've set up the refresh rate using the clock object. Now let's quickly see how the program flows into each other. I have just called onto the drawGrid function in the main part. So if I call onto the drawGrid function, what I'd see is I'd see a board getting rendered. Okay, I'd see a board with lines. And if I click onto the mouse, I would call on to the input to block function, which would give me the row and column, and call on to the getImage function, which would help me paste my picture. And then I'd call on to the winCases, which would check if there is any win along any row or column or diagonal. And then from the winCases function, I'd call on to the result function, which would print my result if it is a draw or a win. If there is no such win, if no win cases are satisfied, my tic-tac-toe game would take in inputs until all the blocks are filled with some image. So now if I run this, I'll play it twice just so I can check both the cases for X win or O's win and to check a draw. So this game is a draw. And if I play it again, I have X1 message printed. So everything is working fine. And if I quit, the screen simply goes away. Cool. Everything worked as we wanted it to work. And this was all about the tic-tac-toe game. Hope you understood whatever we did in the program. Thank you. Hey everyone, we have covered 2 video games in Pygame, the snake game and tic-tac-toe. Tic-tac-toe included a lot of functions and was a little complex. So this time we are gonna do something simple and easy. So see this video more like a practice session than a tutorial because it's just the new idea that we'd be implementing. The modules and code are similar and known. Okay. Making a program in Pygame is all about working with various modules together and going about those 3 basic steps. I hope you understand that by now. In this video, we would be making a color breeze. We would see a shade of color gradually changing to the other, and that color too would be randomly picked. It is going to be a simple program because after 2 video games, I wanted to give a pause so that things don't get too much to handle. Okay. So a color breeze basically means rendering different colors on screen. So we initialize Pygame, get the screen, declare the clock object. We've got C1, C2 and C3, which we would be randomly picking from the range 0 to 255. You can use the random range function or random int. There is just a little difference. Random int includes both the endpoints, whereas random range just excludes the endpoint. It does not include the endpoint. But right now, it would be better if you use randint so that a 255 number is also included, because there are components of RGB that uses 255. There are colors in RGB that uses the 255 number. So basically, C1, C2, and C3 are the red, green, and blue components that would set up the screen color. Then is our while loop, and then the events loop in it. Now these conditions are to change the color, that is get different colors, and we would only change value of any one component, that is C1, C2 or C3, because we want something like a breeze and not colors just popping out of nowhere. The screen's color should change like a shade change, very smooth. Okay. So for that, if the value of C1 is within 255, I hope you know about RGB colors. A component can't have a value above 255. So if the value is within 0 to 255, we add 1 to the existing value. Else, if it's greater than 255, you decrease its value by 255 to make it within the given range. And if it goes negative or 0, you can increase value by 3. And then you give in these three components as fill functions, arguments. Now if I run this, the screen gets various colors, great, and the color transition is smooth as I wanted, but after some time this stops. What if I want to see this again or maybe restart the function? But I don't want to run this again. I want to use the mouse and reset this whole thing. This would not set up the Pygame window over and over and would let you start from a new color, let you see a new color breeze just by a mouse click. We used the mouse module last time, so let me define a function reset. What reset would do is it would simply reset the C1, C2, C3 variables. So let me declare C1, C2, and C3 to be global variables and reset them just like this. Okay. And if I want this function to be called on a mouse click, I would check for an event called mouse button down and call this function. So whenever I click on mouse, the program restarts. Let me print mouse clicked here. Whenever I click on mouse, you would see this message printed. Now if I run this, I see the color breeze, and if I now click on the mouse, I get this message printed, mouse clicked, and the color breeze, it's a new color altogether. I can see a new color on the screen whenever I click on the mouse, so the reset function is working quite fine. You can try to work with some more functionalities, just like we introduced reset. You can add in some more functionalities, like you can try doing this with a text if the text color can be changed like a breeze, or you can add in some music and rewind the music as soon as we reset the color breeze. So please try to work with some more functionalities, think of some more functionalities so that you are comfortable with working with all these Pygame modules. I hope you understood what we did here. Thank you. Hey everyone, we have covered a lot in Pygame by now, but there are some modules that are useful and are yet not discussed. So in this video, first we'd see some examples of draw module. We haven't used the polygon and arc function yet, and then we will talk about the cursor module. We will also discuss a program that will be a base requirement in some of the video games. So let's get started with the draw module. I have this regular code, a very basic one, and if I want to draw a polygon, the coordinates of the polygon's vertices are required. These coordinates make a regular pentagon. Here, the screen is the surface you want to draw on and green is the color of the shape. You can give as many coordinates as you want, and it is not necessary that the shape should be regular. Then to draw an ellipse, you will give in the rectangle's dimension and coordinates around which you want to draw the ellipse. In case you specify a square's dimension in place of a rectangle, you will end up getting a circle. This is basic maths. You can also draw an arc using the draw module. For that, you have to specify the rectangle's dimension. Basically, an arc is from an ellipse or a circle. So to draw an ellipse, we specify the base rectangle's dimensions. And hence, to get its arc, we will do the same. Cool. Along with this, we also need to specify the starting and ending angles. These angles are in radians. It is 90 degree to 180 degree. Please be careful while working with the units. While rotating an image, the arguments of angles were in degrees. Okay, please don't get confused. Now we have used the line function in tic-tac-toe, but this is the lines function. It allows you to draw continuous lines, deviated or undeviated, passing through these mentioned points. 5 here is the thickness of the line. This false here is used for not getting a closed figure. If I make this true, I would have a closed figure if possible. Now let's run this and see if we get the desired shapes. So yeah, I have my polygon, I have the pentagon, I have this zigzag lines made by the lines function. I also have my ellipse and I also have my arc. You just need to note that the arc was taken in an anti-clockwise direction from 90 to 180 degrees. And yeah, that's pretty much it. Now let's move on to the cursor module. So we have 3 types of cursors: the system cursor, bitmap cursors, and color cursors. The system cursors are constants available in the module. We can have cursor hand, cursor no, arrow, crosshair, and a lot more. There's a complete list of it. And this is how you create a system cursor. To create a bitmap cursor, you specify pygame.cursor.arrow or .broken_x or diamond. This would be a black and white cursor that uses the bitmask arrays. And to create a colored cursor, you need a surface. So we have a surface of size 10,10. We fill the color of the surface with sky blue or any color you like. It's the color of the cursor. And then you use the cursor class. You may note that this cursor class of cursors module is a good example of object-oriented programming. This 5,5 is the hotspot of the cursor and needs to be within the surface. Cool. I have initialized the system cursor, and this is just a way to see both the cursors. If I click on the mouse, I would see the bitmap cursor, and if I input alphabet C from the keyboard, I get to see the colored cursor. So this was the cursors module. It was pretty simple. Let's run this and see the 3 cursors. So initially I can see my hand cursor. If I click on the mouse, I see this broken X, which is a bitmap cursor. And if I input C from the keyboard, I see my colored cursor. Cool. So these were the type of cursors. And now let's see the program I was talking about in the beginning of the video. So this program lets you move a picture along your cursor, and it is very useful when you want to move a figure in a video game using a mouse. So for that, you would need to load the image. We have done this many times now. It should be easy to understand. And then I have my rectangular object for my image. I have this moving boolean to save the cursor's state. Now in the events loop, if my event type is mouse button up, like I have released the mouse, moving becomes false. If it is mouse button down, then moving is true, and I would check if the event's position, my cursor is inside the image surface. That is the rect object. And if the mouse touch is in motion and moving is true, I would move my rectangular surface along with my cursor or mouse. That is my event. So if I run this, I should see an image that would move along my cursor. Let's see if that happens. So yeah, I see my image moving along with my cursor. As I move the cursor, the image moves along with it. And this is very similar to the moving object program that we did. But that time we took inputs from the keyboard. This time it's the mouse we are using. And that time we used a figure. We made our own figure using the draw module. This time we are moving an image and we have loaded an image. So this was pretty much about this video. Thank you. Hey everyone, we have seen several applications of the Pygame module by now. In this video, we'll try to make designs on screen using the keys, the arrow keys. From now on, we'll make programs that are simple and quick, but will help us get a better idea of the Pygame module. The more you practice, the more you see the applications of the Pygame module, the more you'll get comfortable with it. So let's get started. I'll import the Pygame module. I'll write import Pygame and then I'll initialize it. Then I'll set up the screen. I'll write pygame.display.setMode and I'll set up the screen size to be 500,500. It fits perfectly in my window. And then I'll also set up a caption. The caption would be design, since I'm drawing a design using the arrow keys. I'll do set caption and write designs. Then I'll write the while loop. Don't worry, I'll get to the main code later. I really like to set up the basic structure first, then get to the main code. So while true, I'll do the for loop then. For events in pygame.event.get, I access the queue like this, the events queue. Then I'll set up the condition if event type, events.type equals pygame quit. Then I'll call the pygame quit function and also quit. So this was the basic structure, the main three basic steps that we write in any Pygame program. Now I'll get to the basic code, the main code. So if I'm saying I want to use the arrow keys to draw a design while I move an object, so it should make sense to you that I'll be using the code. I'll be writing something similar to the moving object code. Okay, so if I'm saying I want to move an object that would leave a trail and that would draw the designs, so I need to describe my figure. So I'll set up the initial position. So let me take x, y, two variables, and set up the initial position to be 100, 100. You can take any position. You can take 50, 50 or 10, 10. Then I'll set up the width and height. I'll describe the size, HEIGHT. The width and height can be 10, 10. Then I'll set up the speed by which the figure should displace each time we press an arrow key. So let it be 10. I'll also give in a delay. I'll write pygame.time.delay of 10 milliseconds in the while true loop, so that we can observe our object moving properly and it does not rush. I hope you can recall this code as we are writing it and you're on the same page as I am. Then we'll describe a variable key, which would be a list. It would be a sequence of booleans that would keep the state of all the keys on the keyboard. So how do I do that? I'd write pygame.key.getPressed, and this would be a sequence of all the states of the keys on the keyboard. And this is how I know which key was pressed, and accordingly I'll use it for the further setup. So now I'll set up my conditions. If I press the up arrow key, I'll write key pygame.k_up. So that would give me the state of the up button. And I'll also write, since I am going up, I'll write y should always be greater than 0. Okay, and I'll decrement y by the speed value since I'm going up. Okay, similarly for down button, I'll write pygame.k_down, and y should be less than the screen size, that is 500 minus the height. Cool. I'll increment y now. Since I'm going down, I'll increment y by speed units. Now I'll do the same thing for the right and left key, pygame.k_left, and x. Now I'll talk about x because I'm pressing the left key. X should be greater than 0 always, and I'll decrement x by speed units. I'll do the same thing for the right key. I'll write pygame.k_right, and x should be less than 500, my screen size minus the width. Okay, then I'll increment x by speed units since I'm going right. Okay, I hope you remember how we accessed that key list. We use the constants, the key constants. Okay, and yeah, cool. I hope you remember this. I hope you can recall all this. Then I'll draw my figure. I'll do pygame.draw dot rect. I'll take a simple rectangle. Screen is the surface I want to draw on. Then the color would be white. It looks good on black background. And then the rect values would be the initial coordinates and its size, width and height. Fine. Then I'll update this complete thing. Fine, we are done with the code. Now you might notice I haven't used the screen fill thing. Why haven't I used it? Because I don't want any single color on my screen always. As my object moves, it should leave a trail now. Okay. If it is the only difference between the moving object code and the design code. Okay. So I hope you get this. I don't want any single color on my screen. That's why I'm not using screen fill color, a screen fill function. Cool. Let's run this and see if it works as we want it to. So yeah, if I now run this, I can see the object, and if I press the right button, it goes right. If I press down, it goes down. If I press left, it goes left, and it's working very fine. It gives us various patterns. As I'm pressing the arrow keys, it moves accordingly. And this is very useful when we are making a maze kind of video game. It helps you track your object. I hope you got whatever we did in the program. I hope you were able to recall the things. Thank you. Hey everyone. So today we're gonna do something new. We're gonna display the text that the user inputs. So basically whatever we type in, we're gonna see that on the Pygame window. We won't use any new module. It's just the utilization of the available modules, whatever we have learned till now, as per the program's requirements. So let's get started. So I'll import Pygame first. I'll write import Pygame, then pygame.init to initialize it. Then I'll have my screen. I'll write pygame.display.setMode, and that would be 500, 500. Then I'll also set up a caption. My caption would be user input. So I'll write pygame.display.setCaption user input. Fine. Then I'll do the while true loop, the game loop. I told you last time that I'll like to make the basic structure first, then do the rest of the code, then write the rest of the code. Then I'll have my events loop. I'll write for events in pygame.event.get. If events type is equal to pygame.quit, I'll check the condition, then I'll quit. I'll call the quit function of Pygame. Yeah. Then I'll update this entire thing. I'll write pygame.display.update. So yeah, that's the basic code. That's the basic 3 steps of any Pygame program. Now, since I'm saying I want a user inputs, I should of course have an empty string to which I'll concatenate whatever the user inputs. So let me take this user underscore IP as the variable, as the empty string. Then I'll have my font, because of course we need to take a font. We are working with text in Pygame. So please remember how we display text on screen. It would be similar to that. So I'll write font equals pygame.font.sysfont, and you can take any font you like. You can take Georgia, Arial, Calibri. I have taken French script right now, and the font size would be 40. Cool. Then since I want a rectangular box in which I'll input the text, I will initialize this text box. Since I want to manipulate this later in the code, I'll do this I'll use this rect module I'll write pygame.rect, and I'll give in the arguments the initial position, that would be 75, 75, and the size of the box, let it be 100, 40. So the width is 100 and height is 40. Fine. Okay, let's not keep this 40, let's make it 50, because I want a margin of 10 of 5 each at above and below the text, so that things don't overlap and don't seem to be clumsy. Cool. Then I'll have this active boolean that will tell me if I can start writing, if I can start typing in the text box. And what will indicate me this is this color variable. So initially this would be purple, but when active is true, I'll switch this color to red so that I can know that I can now start typing. Whenever I take my cursor to inside the text box, I'll make this active to be true. So how I do this, I'll do this in the while true loop and in the for loop. I'll check if my events type is mouse button down. Then if I'll check if I have clicked my mouse inside that text box. Okay, so I'll write if text box dot collide point and events dot position is true. So I'll make active equals true. Cool. Otherwise, I'll make active equals false. Maybe you have clicked outside the screen or outside the box, so then active should remain false. Otherwise, it should be true, made true if my cursor is within the text box. Fine. And now if I've started typing, so I'll write if events.type equals pygame.keyDown. And if active is true, maybe it can be the case that you have clicked inside the box and then clicked outside and then started typing. So that would not work. Then you should not get any text displayed. So I'll check if active is true. And then I'll have these two other conditions. If I press backspace, so I'll write if events.key equals pygame.cabe underscore backspace. I'll slice the string. Okay, I hope you know about list and string slicing in Python. So what I'll do is I'll make this user underscore IP string as a sliced string. I'll slice the last character out of the string. And how do we do that? We mention the stop index to be -1. So the last character is removed now. Else, if we do not press backspace, we give any keyboard input, we concatenate that Unicode. Okay, so I don't need to make several cases for this, that if I've pressed this key, I should append this or concatenate this to the string. I would just write events.unicode. So it is very convenient. Then I'll fill my screen with a color. You can take any color. I'll write screen.fill. I'll take pink. And now it's time I set up the color and get my indications that I can start writing or not. So I'll say if active is true, I'll take the color, I'll assign the color variable, the color red. And if it is not, if active is false, I'll write else color is equals to pygame.color purple. Cool. Then I'll draw my rectangle. So I need to see a box. I need to visualize a box. So I'll write pygame.draw.rect. And I want the screen to be the surface on which I draw. And then I'll have this color variable, the color of the box. Then the parameters of this rectangular box are given by text box. Cool. And you of course need to mention this width, otherwise you'll see the entire box to be of the purple or red color according to the situation. I don't want that. I just want the border to be of some color. Fine. Then I'll have this surface on which I render my text. So you can see I have not rendered it here above, but I'll render it in the while loop, because every time the user gives an input, I want that text on the screen. So I've rendered it here and not above outside the while true loop. So I'll write surf equals to font.render, And what is my message? What do I want to output on the screen? It's the user underscore IP variable, that string. I want anti-aliasing to be true, and the color of my text, I'll take it to be orange. You can take any color. Fine. Now let me get this surf variable onto the text box. So I'll do screen.lit, and what I want to get on which surface, I want to get surf, this text, on my text box, and I'll have a margin of 5 units so that things don't overlap. So I'll write textbox.x. So I've accessed the initial x position, x coordinate, and added 5 to it, and then I'll write textbox.y. So I'll increase the y coordinate by 5 to have a margin of 5 units. And then yeah, then I'll also do this thing. Let me write the code first, then you might understand. I'll write textbox.w. So I've accessed the width, and I'll take the maximum of 100, my default width, and the surf variable's width. So surf is my surface, the text surface, and I'll use the getWidth method to get my current width of the text, and add 10 to it again to have a margin and so that things don't overlap. So what I've done is, maybe whatever the default size of my text box is, you outgrow that. Maybe whatever the text you have input, that's longer than your default box size. So if my text is smaller than the width, the default width, fine, no problem. And if it is greater than the default width, it'll take the width of the text. Cool. And then I'll update this. I've already written this. And then I'll set up the frame rate. Since I've taken the clock object already, I'll write clock.tick and 50. Fine. So if I run this now, I see a purple outline box, and if I click, I take my cursor inside the box, I see the border to change its color and become red, and I can start typing now. I can type in anything, and you can see after a certain length, when the width of my text increases, the width of the text box also increases. So that's what it does, this max function on the 38th line. It lets you decide when to increase the box size, our rectangular box size. So everything is working as we want it to. We can type in easily, and yeah, that's pretty much it about this program. I hope you understood whatever the code was, whatever we wrote. Hey everyone, today we're gonna create a button in Pygame. Let's first think what a button does so that you have the basic idea what we'll be doing in the program, how we'd be coding. So whenever you click on a button, a certain task is performed, a function is called. So here, this function is going to be quit function by Pygame to keep it simple and easy. Whenever I click on that rectangular button on the screen, the program should stop and the Pygame window should go away. Also, I'd like to add in a functionality. Whenever I hover over that rectangular box, over the button, there should be a shade change, there should be a slight color change, so that I can know, the user can know that right now the cursor is over the button. Cool. So let's start coding. As usual, I would write the basic steps first and then get to the main code. So let's import Pygame. I'll write import Pygame. I'll initialize it. I'll write pygame.init. Then I'll set up the screen. I'll write pygame.display.setMode 500, 500. That's the screen size. Then I'll also set up a caption. So my caption would be Pygame button. And then I'll have my game loop. I'll write while true. For events in pygame.event.get, if events.type equals pygame.quit, I'll call the quit function. And then I'll update this entire thing. I'll write pygame.display.update. So this was the basic code. Now let's get to the main code. Since I want a quit button, I should have quit written over that rectangular box. That would be my button. So for that, I'll use the font module, of course. I need to display the text quit. So for that, I'll write font equals pygame.font.sysfont. And let me take the font Georgia and the font size to be 40. Let's keep it bold. And then I'll render this over the surface. So I have the surf variable. I'll write font.render, and my message and my text would be quit, and I want anti-alias to be true. And then the color of this text, let it be white. Fine. Then I'll have this button that would act as the rectangular box that would be my button. So I'll initialize its initial position and its size. So I'll write pygame.rect, that its initial position be 200, 200, kind of in the middle of the screen, and its size be 110, 60. So its width is 110 and its height is 60. Fine. Then I'll fill my screen with some color. You can take any color. I've taken pink. Then inside this for loop, I'll put in this mouse button functionality. I'll check if my events type is mouse button down, if I'm using my mouse, and check that my cursor is inside this button, this rectangular box. Okay. And how would I do that? I'll write if button.collide point, in brackets the argument would be events.position, and then I'll call the quit function. I'll write pygame.quit. Fine. So this is how I checked if my cursor is within this rectangular box, is over the button, and if it is so, if it has been clicked, then I'll call the pygame quit function. Fine. Now, since I wanted to add that color change functionality, that hovering and shading functionality, I'll get my mouse position, I'll get my mouse coordinates, the cursor's coordinates. So I'll write a comma b equals pygame.mouse.getPosition. So a would be the x coordinate and b would be the y coordinate. To avoid confusion, I've taken a and b because we'd be already using the x and y coordinates of my button, that rectangular box. So let's not have any confusion. So my mouse coordinates, the x coordinate of my mouse is a and the y coordinate of my mouse is b. Fine. Now I'll check if this mouse coordinates, if these mouse coordinates are within my box. So for that, I'll write if button.x, the x coordinate of my rectangular box, is less than equal to a, the x coordinate of my cursor, is less than equal to button.x, which is the x coordinate of my rectangular box, plus 110, that is the size of my rectangular box, that button. Fine. And also I want button.y, the y coordinate of my rectangular box, to be less than or equal to b, the y coordinate of my mouse, of my cursor, to be less than or equal to button.y plus 60. So the y coordinate of my rectangular box plus 60, because that's the height. Fine. I hope you can visualize this, you understand this. And then if it is so, I'll draw a rectangle. I'll write pygame.draw.rect, and screen is the surface I want to draw on. I'll give in this color. This is a lighter shade of gray, and the rect value is given by button. Fine. And else, if it is not so, if the cursor is outside this button, then I'll give in this color a darker shade of gray. That's the default color. Fine. And then I'll get my text on the surface button by using blit. So I'll write screen.blit. Surf is the surface of the text, and this is for having margins. For I've done +5 with the button's initial coordinates so that I have a margin and things don't overlap. The text doesn't overlap with the borders. Okay, then I'll update. So I've already written that. Let's run this and see if my button works. So now if I run this, I can see my quit button, and if I hover over this button, I see a shade change. It's a lighter shade of gray whenever I hover over this. My cursor is over this button, and if my cursor is outside somewhere, not on this button, then it's a darker shade of gray. Cool. So if I click on this button, the program should stop. Let's see if that happens. Yeah, so the window went away and the program stopped. So I call the quit function using this button. You can call any other function. You can call in the function to play a song. You can call in the function to display a text. So this was all of it, and I hope you understood how to create a button in Pygame. Thank you. Hey everyone, by now we have seen several applications of Pygame. We have practiced a lot. We made designs using the arrow keys, displayed user inputs on screen. We also made buttons in Pygame in the last video. Today we will program an animated circle. So the circle would move around on the Pygame window. Let's write the code for it. I'll import Pygame, initialize it then. I'll write pygame.init. Then I'll set up the screen. Write screen equals pygame.display.setMode. Let the screen size be 500, 500. Then I'll also give in a caption. I'll write pygame.display.setCaption. Let the caption be animated circle. And then I'll go to my game loop. I'll write while true. You should be very comfortable doing all this because by now we have written this a lot of times. And then I'll have my for loop. I'll write for events in pygame.event.get. I'll check if events type equals pygame.quit. Then I'll quit. We'll call the quit function by Pygame and I'll quit. Okay. I'll update the screen. Write pygame.display.update. That's the basic framework. Let's get to the main code. Since I want my circle to move around, I'll need its initial position. Let that initial position be 5x, y and equal to 200, 200. You can take any starting position. I've taken 200, 200. Then I also need to set up the speed along both the directions. So along x direction, let it be xp and let xp be equal to 5. And along y direction, let it be yv and equal to -5. So what is this clause of plus and minus? If you're giving the speed along the x direction as positive, your object should go towards right, otherwise it should go to left if the speed is negative. Similarly, for y direction, if you're giving the speed to be negative, it should go upwards, and if it is positive, if the speed is positive, the object will go downwards. Okay. So the speed would tell you how much the displacement would be at a time. Then I'll have my clock object. I'll write clock equals pygame.time.clock to set up the frame rate later. Now I'll have a screen color. I'll write screen.fill. So let me fill my screen with color sky blue. Then I'll also need to draw the circle I need to move around. So I'll write pygame.draw.circle and screen is the surface I'm going to draw on. Then the color, let it be orange. Then the center coordinates are given by x and y, x, y. Then this radius, let it be 10 units. Okay. Now after this for loop, outside this, I'll increment the x and y coordinates so that I can see my circle moving on the screen. So I'll write x plus equals xv. I've incremented x coordinate with xv units by xv units. And similarly for y, I'll write y plus equals yv. And to keep these x coordinates, x and y coordinates within the boundaries within the screen, I'll write if x is greater than 490 or x is less than 10, I'll change the direction. Okay, how do I do that? I'll change the sign. Okay, I'll change the sign of the speed. You can even reallocate the position, but that would look like the circle is appearing out of nowhere at a sudden position. That won't look nice. So I want the motion to be regular and fine. So that's why I'd be changing the direction rather than reallocating that coordinate. Okay. Similarly for y, I'll write if y is greater than 490, I'm keeping a margin of 10 units, or y is less than 10, I'll change the yd. Cool. Now after that, I'll update and have my clock object. I'll write clock.tick, let the frame rate be 50, and let's run it and see if we get what we really want to see. If we can see our circle moving uniformly. Let's run this. Now if I run this, I can see my circle moving around in various directions, changing its direction as it hits the boundaries. And everything works fine. If I quit, the screen goes away. So this motion of the circle is not defined. In the next video, we will define this motion of the circle. The path along which the circle moves would be some function. So this was pretty much it for this video. I hope you understood whatever we did. Thank you. Hey everyone, as I told you in the last video, we would animate the circle along the graph of a function. That's what we are going to do in this video. We will try that our circle moves in a sine pattern. The function I've picked is sine. If you don't know how a sine wave looks like, this is what a sine wave looks like. You can see that along the x-axis you have the angles, and along the y it is the sine value of these angles, and it looks like a sinusoidal wave. So you need to given these angles in the sine function, and you can easily find the y coordinate. For the sine function we will use the math module, and we will give in these x and y coordinates as the argument while we draw the circle. So that will put our circle at the required position, and the output motion would look like a sine pattern. Fine. Let's write the program now. I'll import Pygame. I'll write import Pygame. Then I'll initialize it. I'll write Pygame.init. Then I'll set up the screen. I'll write Pygame.display.setMode. And I'll given the screen size to be 1000,500. I've taken such a large width so that I can see a number of waves, and I can easily observe that sine pattern formed by the ball. Then I'll start my while true loop. I'll get to the game loop. I'll write while true. For events in Pygame.event.get, if events.type equals Pygame.quit, so I'll check in the condition, I'll call the quit function. Fine. Pygame.quit, and I'll quit. And then I'll update this. I'll write Pygame.display.update. Cool. So this was the basic code. Let's get to the main code now. Since I said I'd be using the math module, I'll write import math. I'll import the math module. Now I should think that from where we will give in the inputs, from where we should find the x coordinate. Y coordinate, we can easily find the y coordinate because that's just the sine function of the x value. So where we will get the x value from, we will get it from the time. Okay, but you might say that if we get the running time of the program, then it will exceed continuously and we won't see our ball once it has passed our screen. For that, I'll use the modulo operator. I'll find the times modulo by 1000. This is how I'll write it. So the getTix method gets me the amount of time for which the program has been running right after initializing Pygame. Otherwise, this won't work. If you haven't initialized Pygame, this won't work. Okay, and I'll also divide it by a number. I'll divide it by 3 so that I can get a slower speed. The ball doesn't run away. And I can notice that the ball moves in a sine pattern. Fine. Then let me put this x equal to t. Okay. And for y, I will put it into the sine function. So I'll write math.sine t by 50 into 100 plus 200. Okay, so I've divided it by 50 for the wavelength. So I want to keep shorter wavelength so that I can see many waves and I can easily observe the sine pattern. Now if you increase this, you can increase this to 150, then the wavelength would be increased and you'll see less number of waves. This 100 is for defining the amplitude. If you increase this, the amplitude would increase, and if you decrease this, the amplitude would decrease. 100 defines the amplitude, so 100 is the amplitude of my wave, and I've added it with 200 so that I can see my wave in the middle of the screen and not at some corner, otherwise the sine wave will overlap with the boundaries. Okay, then I'll fill my screen with some color and I'll draw my circle. Let the screen fill color be pink, and I'll use the draw module to make the circle. So screen is the surface I want to draw on. I'll give it a color. Then x and y are my coordinates, and 10 be the radius of the circle. Then I'll update. I have already written this. So let's run this and see if we observe our circle in a sine pattern. So yeah, I can see my ball or circle moving in a sine pattern. It's very similar to the graph I showed you before. Now if you can't observe it, what you can do is you can rub this line screen.fill just to observe for once the sine pattern of the ball. You can rub in this line screen.fill. I hope you remember we did the same thing while we wanted to draw patterns using our object, using the arrow keys. We wanted to see the trail of our object drawn. Here too, the trail, that is the sine pattern. To see that, you can rub in this line. And now if I run this, you can actually see the sine graph. And so yeah, our ball moves in a sine pattern. Now you can use other functions also like cosine or tangent from the math module. So this is it for this video. Thank you. Hey everyone, today we're going to do something different. We would use classes in order to make a Pygame program, rather a game. So I would try to build a collision game. I would have this man, and if he hits the bricks falling from above, the game is over. Simple, okay? So in Pygame we have a sprite module for working with classes. Sprites are objects. If you don't have much idea about classes and objects in Pygame, basically, they are a convenient way of grouping data and code into a single entity. Sprite module is a very good way of working with classes in Pygame. So for the algorithm, what I would do is, I would first have a man class that would be of the sprite type, and I will also have a brick class. Now both of them must have the init function where I load these images and get their rectangular surfaces. Then we would have the move function in both the classes. We would move the man by giving key inputs from arrow keys, and the movement of bricks would be programmed, and the initial position of the bricks would be randomly picked by the random module. Now using the sprite module, I would check in the game loop if there is a collision between these two image objects. If there is, I would display the text game over. Okay, now let's start writing the code for it. So let me write the basic code quickly. I'll import Pygame. Then I'll initialize it. I'll write pygame.init. Then I'll set up my screen. Write screen equals pygame.display.setMode, and the screen size is 500, 500. Then I'll set the caption. I'll write pygame.display.set caption, and the caption, let it be collision game. Okay. Now for the while loop, I'll write while true for events in pygame.event.get if events.type equals pygame.quit. I'll call the quit function by pygame. I'll fill my screen with some color. I'll write screen.fill white, and I'll update this. Let me use the flip function. I'll write pygame.display.flip, and that's the basic code. Now let's write the main code. Let's get to the main functions of our game. Now since I said I'd be working with random module because I need the bricks to be randomly falling from anywhere. So I'll import random module too. I'll write import random. Okay. Then I'll have my clock object. I'll write clock equals pygame.time.clock. That's my clock object to set up the frame rate later. And I would need to set up the speed variable for the movement of bricks. This is just the initialization. We'll use this later. You'll get an idea why we have initialized it here. And I also need to display that text, game over, so I set up the font. I'll write font equals pygame.font.sysfont, and let it be Georgia and 60 as the font size. Cool, so I have these variables initialized. So let's get to the two classes I talked about, the brick and the man class. So let me define the brick class first. I'll write class brick. So that's how you define a class in Python. And since I want to inherit the sprite class, I'll write pygame.sprite, which is the module, dot sprite, which is the class. Okay. Sprite is the class in this sprite module. Okay. So it might be confusing in the beginning, but just try to think and understand. You'll get a hold of it. Okay. Now I'll have this init function. I'll define init. I'll write def underscore underscore init underscore underscore and self. Okay. So I'll inherit this sprite class. So I'll write super.init. Super.init. It's a way in Python how we inherit the classes. Base classes. Okay. So now I'll load my image. I'll write self.image equals pygame.image.load. You should have a little basic idea of classes in Python, otherwise it might be too much for you to handle for now, because we are already working with Pygame, that is new for you, and then we are again having a new thing that is classes. So you might not get comfortable with it. So please try to understand the classes first and then get to the Pygame code. Fine. So I'll write self.image equals pygame.image.load. So my image is in collision folder. It's just how we displayed an image in Pygame earlier. Just the difference is that right now we're doing this in a function inside a class. Okay. Then I'll scale this image of mine. I'll write self.image equals pygame.transform.scale self image. What I need to transform, what I need to scale is the self image, and I need to scale it to size 40,40. Okay, then I need to get the rectangle, so I'll write self.rect. These are just variables but of brick class. So that's how you write it. I'll write self.rect equals self.image.getRect. I got the rectangular surface and I need to define the center. So my center would be randomly picked for these bricks falling from above. So I've used random.randint. 40 comma 500 minus 40, I've kept margin of 40 either side, just so the boundaries and the bricks don't collide, they don't overlap. Okay, and yeah, then I'll define the move function for the movement of the bricks. How they have a motion, right? They are falling from above. So how I'll do it, I'll write self.rect.move in place, and the arguments are 0 comma speed. So my speed was 5, and I'm just giving a speed in the y direction because I want it to fall from above, and there should not be any movement along the x-axis. The brick is just falling from above directly towards the ground. And move in place, what does move in place does is, from an object's coordinates, it moves it with respect to that position, what the speed we have mentioned. Okay, so like if the coordinates right now are 400 comma 400, and I've mentioned 0 comma speed as the move in place arguments, after this function is called, the final coordinates would be 400 comma 405. Okay, I hope you get what I'm trying to say. And I'll put in some conditions that once the brick has traveled the entire screen and not hit the man, okay, then what should happen? I'll write if self.rect.top is greater than 500. Now I just quickly wanted to show you what this rect top and dot center means, which coordinate of the entire rectangle I'm talking about. You can see it in this picture. So I hope you get the idea what is dot top, which coordinate I am talking about, and what is dot center. There are two different coordinates of the rectangle. Okay. Now, if it is so, if the rectangle's top coordinate is greater than 500, that is, it is out of the screen now. Now I should reallocate this top coordinate to 0, and the center should be randomly picked again. Okay. Again, I have kept a margin of 30 and 100 over here so that things don't overlap. Okay. Cool. Now I'll have my man class. Again, I'll write class man, very similar to the above class, and pygame.sprite.sprite. Okay. Then I'll have my init function again. I'll write self in the argument. With the super keyword, I'll inherit the sprite base class. I'll again load the images, but I'll load that image of scared man now. It is in the collision folder, so accordingly I've mentioned the path. Then I'll scale this. I'll write pygame.transform.scale self image 100 comma 150. Okay, and I'll write self.rect equals self.image.getRect to get the rectangular surface and define its center. It's just the initial coordinates of the image that I've loaded of the scared man. Let it be 200 comma 420. Okay, and then I'll define the move function, how the man moves. Okay, so since I'd be taking inputs from keys, the arrow keys from the keyboard, I'll again write keys equals to pygame.key.getPressed. So I hope you remember this was a sequence, this was a Boolean sequence that contained the state of all the keys on the keyboard. If it is true, then that key is being pressed. Now I'll check if keys pygame.k underscore left. Then I'll write self.rect.move in place minus 5 comma 0. So I want to move it towards the left. Okay, so I'm subtracting. We discussed this earlier in earlier programs. And if we want to move left, we'll decrease its coordinates. Okay, so I'll decrease it by 5. And if keys pygame.k underscore right self.rect.move ip 5 comma 0. Okay, so if it is if I've pressed the right key, if the user has pressed the right key, the man will move towards right with 5 units. Okay, now I'll declare objects of this man and brick class. M1, I'll write M1 equals man and B1 is equals to brick. So this is how we declare objects in Python of a class. So these are my two objects. Okay, and now I'll have a variable bricks. I'll write equals pygame.sprite.group. So I'll declare this bricks to be a group. Okay, so what a group is, it's a sprite module functionality. It's a container class to hold and manage multiple sprite objects. Okay, now to this group, I'll add B1. Okay, so this is a bricks group. Okay, and to that I've added B1, that object, that brick object. Okay. Now I'll have another class in which I'll put everything, all the objects that I've declared. Okay. Now all sprites equals pygame.sprite.group. Again, this is another container class. Okay, and I'll add hem1 and b1 to this group. You'll get it in a minute why I have declared these groups. Okay, bricks and all sprites. Now let's get to the while true loop. Now for entity in all sprites, screen.split entity.image, comma entity.rect, entity.move. Okay, what I have done is I'll traverse all that is there in the all sprites group. That is why I've declared all sprites variable, because I need to put each of those objects on the screen. So that is how I've done it. I'll write screen.split entity.image entity.rect, so I've got that image on that rectangular position on the screen. Okay, now entity.move, I've called on to that move function in the respective classes, and according to the move function my objects would move, my images would move. And I'll also, now is the main part, I'll check if that sprite objects collide with any of the other object. Okay, so I'll write if pygame.sprite, because it is a sprite module function, dot sprite collide any. It's a simple test if a sprite intersects anything in a group. Okay, so m1 comma bricks. Okay, m1 is the man. We have only one man, but we'll have a number of bricks. Okay, and then if it is so, if this returns true, then I'll render the font that I declared above. I'll write text equals font.render. What is my message? It is game over. I want anti-alias to be true, and the color, let it be orange. Fine. Then I'll get this on the rectangle. So text rect equals text.getRect center. That will be 500 double slash 2. 500 double slash 2. Okay. So I got this text at the center of the screen, and I'll use split again to get this text on the rectangle. I'll use dot flip function so that I can update this. And just so I can visualize this text, I can see this text that the game is over. I'll use this time module. I'll write time.sleep for 2 seconds so that I can see that the game is over, and then I'll quit. Okay, otherwise you'll just see the game over text is blinking and going away and the screen goes away. Okay, that wouldn't look good. So I'll also need to import time module. I'll write import time. Yeah, that's it. So I'll also need to set up the frame rates. I'll write clock.tick and 40, let the frame rate be 40. Okay. Now let's play this game and let's see if everything works properly as we have defined. Now when I run this, I can actually see the bricks falling from above. I can move the man using the left and right arrow keys. I guess the speed is a little slow, so let me change the frame rate to 60 so that the game becomes a little fun to play and a little complex. So the bricks are now falling faster, and when the man and the brick collides, the game is over. I have this text and the screen goes away automatically after 2 seconds. Cool. So this was it for this program. And you can also think about how you'd gradually increase the speed. So you can think of levels. For that, you might need to declare some user events. Please think about it. Please look for what you can do. And this was it for the program. Thank you. Hey everyone, today we're gonna talk about another general function of a character in a video game. If you have a player in the video game, you might need to add the jump function. You might need your player to jump. So that's what we're gonna program today. Let me discuss first what we will do in the program. We will have this rectangle made by the draw module, then we would use the key module to move the rectangle up, down, left and right. And we will have one more key that we would use to jump. Let that key be spacebar. So let's code all this. I'll import Pygame. I'll write import Pygame. I'll initialize it. Then I'll set up the screen. I'll write screen equals pygame.display.setMode, and the screen size is 500, 500. I'll give in the caption. I'll write pygame.display.setCaption and let the caption be jump. Then I'll do my while loop. I'll write while true for events in pygame.event.get if events.type equals pygame.quit. Then I'll call the quit function by pygame and I'll quit. I will also set up my screen with some color. Write screen.fill. This is a lighter shade of green. And then I'll update this. I'll write pygame.display.update. And I'm done with the basic frame structure. Now I would need to set up the basic variables that I would use in the program. So one would be the size, height, width, and the initial position of the rectangle. I would move around. So you can use the rect class, or you can initialize the parameters just by taking variables. And so I've used the rect class. I'll write my rect equals pygame.rect. Let the initial position be 200, 200, and the size, the width be 10 and height be 20. You can even take a larger rectangle. Then I'll have the speed variable, let it be 5, the amount of distance the rectangle travels at once. And I'll have this jump variable, which would be a boolean. I'll set it up to false so that I can know when the object has to jump or not. You'll get the use of it later in the code. Then you have this jump c variable, which is equal to 10. I'll put this equal to 10. This is the jump speed, the amount of distance it travels at once when you jump, or you will click the space bar. So we will use this later in the code. Now, inside this while loop, I will define the movement of the rectangle drawn. I'll write keys equals pygame.key.getPressed. So keys is a boolean sequence, as we have discussed a lot of times by now. It stores the states of the keys on the keyboard as true or false. If the key is pressed, its state is true. Now accordingly, I will check in which direction the object should move. This is exactly the same thing as we did in moving an object. So try to write this piece of code yourself. It would help you practice. Now I'll check for the left arrow key. If the left arrow key was pressed, I'll write if keys in square brackets pygame.kleft. So this is how we access the state of the left arrow key, and my_rect.x. So this is the x coordinate of my rectangle, the object, is greater than 0. Then I will decrease the x coordinate of the rectangle by speed units. So I'll write my rect.x. If x as the x coordinate, minus equals speed. Okay, I hope you remember, if we need to go towards left side, then we decrease the x coordinate. Now for the right arrow key, I'll write if keys pygame.kRight, if x as the right arrow key, and my rectangle.x is less than 500 minus rect.width. dot w would access your width. This is just for keeping the rectangle, complete rectangle within the boundaries. I will increase the x coordinate by speed units. So I'll write my rect dot x plus equals speed. Fine. Now I'll check for the up key. So I'll write if keys pygame dot k underscore up, and my rect is greater than 0. I'll access the y coordinate now since I'm talking about vertical motion. I'll write my rect dot y minus equals speed. Okay. This is the normal motion of the rectangle. Okay, I also need to talk about the down key. If keys pygame dot k down, and my rect dot y, the y coordinate, is less than 500 minus my rect dot h. Since we are talking about the vertical motion, I have accessed the height, not the width here. My rect dot y plus equals speed, since we are moving downwards. Okay, fine. So this was something we had already done, but now we'll move on to the jump function part. So I'll write if jump equals false. I'll check if jump is equals to false. This is the initial condition right now. And then I'll check if keys, and basically I have pressed the space bar. I'll write if keys pygame dot k underscore space. I'll access the state of the space bar. If it has been pressed, I'll make jump equals to true now. Okay, I'll reassign its value. So if you actually analyze what would happen when the rectangle jumps, it would cover a lot of distance vertically above, more than it normally covers when we press an arrow key. So I'll put this in the else condition. Let me write it first. If jump c is greater than or equal to minus 10, I'll check if the object is back at its place. My rect dot y minus equals jump c into absolute jump c into 0.5 jump c minus equals 1. So let me explain now. You should get that if the rectangle is jumping, we will decrease the y coordinate just like the up arrow key, but by a larger value. So that value is product of jump c into absolute jump c and 0.5. And after each decrement of y coordinate, I will decrement the jump c by 1. Jump C keeps the count how many times there would be this kind of y coordinate decrement. Now you can think once the jump C value decreases and reaches 0, you need the rect to come back to its original position. But for that, you will increment the same that you decremented to the y coordinate. So here is the role of this absolute function. Since jump C is negative, if you don't use the absolute function, you will end up decrementing more and the rectangle will not come back to its original position. So all this will basically run a loop till the jump c becomes minus 10. As you went up 10 times, you need to come back the same amount of times. Okay. Now else, I will write jump c equals 10. I'll reassign jump c and jump equals false. So I've reassigned these two variables just in case you click on the spacebar again, the spacebar is pressed again, the values are reassigned. Okay. Now I've filled the screen with some color and I'll draw the rectangle now that would be moving around. So I'll write pygame.draw.rect screen and I'll give in some color, let it be purple, and my rect.x, my rect.y, my rect.w, and my rect.h. Okay, so these were the parameters x, y, w, and h were the parameters of the rectangle I would draw. Okay, now this is it for this program. Let's run this and see if the rectangle jumps. So here's the rectangle I made. and I'll press the spacebar first. Okay, so rectangle jumps very well, and the forward, backward, and down and above keys work fine. Left, right, up and down keys work fine. Now you can even combine the two keys. If you press the spacebar and the left or right arrow key, there is a combined motion. You can see like this. It's a kind of a parabolic motion. Okay, so yeah, this was it for the program, and I hope you understood whatever was done. Thank you. Hey everyone, today we're gonna again display text on Pygame window, but in several lines. So that would make use of some basic Python, but with Pygame. So that's going to be a little different than what we usually do to display text on screen. Let's get to the code right away. I'll import Pygame. I'll initialize it. Write pygame.init. Then I'll set up the screen. I'll write screen equals pygame.display.setMode and let the screen size be 800, 500. Then I'll give in the caption. I'll write pygame.display.setCaption. Let the caption be text. Then I'll get to the while loop. I'll write while true for events in pygame.event.get if events.type equals pygame.quit. Then I'll call the quit function by pygame and I'll quit. Then I'll fill the screen with some color. I'll write screen.fill and let it be pink. And then I'll update. I'll write pygame.display.update. So we're done with the basic structure. Let's get to the main code now. Since I want to display some text, I need to define that. So let me take this variable text. Let it be equal to a string. I will write hello everyone /n. So I need to indicate that there is a new line beginning. We are trying to display text on Pygame window. Okay, so that's my text. That is what I want to display on the screen. Since I want to display the text like usual, I'll have this font variable. I'll write pygame.font.sysfont and let the font be ink free. You can take any font and the font size be 60. You can take any font size. Now just think what would be different while rendering text in different lines. How would it be different from just displaying text on screen? So when we display text on screen, usually you might have noticed if the sentence is a bit long, it runs out of the screen and it is not visible. So we need to check after rendering each word on screen if the screen is ending here. If not, we can print the next word in the same line, else we would move to the next line. Okay, so for that, I would need to define this display text function. I'll write def display underscore text. And I'll give in the argument surface, on the surface on which I want my text, then the text, the message I want to see on the screen, the position, POS, the starting position of my text from where I want my text to start, the font of the text, and the color. Okay. So in this function, I would get the words separately in a list and render them one by one while checking the screen's ends. Okay, so for that, I'll have this collection variable. I'll write collection equals for word in text dot split lines. So what I have done is this text dot split lines would split this text, the message you have passed into the argument, into several lines, into several elements of a list. So hello everyone would be one element of the list, and we are trying to display text on Pygame window would be another element of that list. That's what we have, and we would be traversing this list. So it has two elements right now, and then to get each word here, what I'll do is word dot split. I'll give in the argument as the space, and I'll put this entire thing in square brackets so that it becomes a list. So basically this would be a 2D list, as the text split lines would already give you a list, and in that list you further use the split method that makes another list of words for each sentence. Okay. Now to give in space between different words, I will have the space variable. I'll write space equals font dot size. I'll give in the space as argument and 0. So font dot size and any character in the argument would give you a tuple which has the width and height of that character. You get that, right? For a font, two characters would not possibly have the same width and height. So 0 would give you the 0th element of that tuple would give you the width, and the first element of that tuple would give you the height. Right now I am just working with the height because that is the amount of space I want to leave in between two words while rendering two words. So, okay, then I have this x comma y equals position. So this x and y would keep a track of current position, and it would be used for checking if the screen has ended and to move to the next line. Okay, now we'll traverse this collection 2D list. I'll write for lines in collection and for words in lines. Now I will render the text. I'll write word underscore surface equals font dot render words comma true. I want anti-aliasing to be true, and the color that I passed in the argument for this function that will be passed here. So I have rendered this text, the word. I am accessing each word now, and I have rendered this word on a text on a surface, on a rectangular surface. Now after rendering we use split usually, but before that I need to check if there is still space or the word would be rendered in a new line. Okay, so for that I'll get the width and height of the surface I just rendered. I'll write word underscore width word underscore height equals word surface get size. So this would give me two variables, the width and height of the rectangular surface that was just declared, and I'll check if there is a need to go on to the next line. So I'll write if x plus word width is greater than equal to 800. So x was my initial position from where I wanted to start the text, and adding that to the word width would be like the entire width of the text. If it is greater than or equal to 800, now that position, that x coordinate, if it is greater than equal to 800, the width of my screen, okay, then what I'll do is I'll reassign x. I'll write x equals position 0, the x coordinate of the first word, and for y, since I want to go to the next line, I'll increment y by the word height. Okay, I hope you get it, that to move on to the next line, there is no such thing while rendering text on Pygame, any lines, no lines are there. So I'll increment y by word height, so that will give me a new line. Okay, now after checking the condition, I can use the blit function. I'll write surface dot blit word surface comma x comma y. So x comma y would be the position where I want this rectangular surface, this word surface, to be there, and so I got the rectangular surface on the screen. And to update x every time, I will increment it by the word width and space. That was the width of the space. Okay, so let me write this down. I'll write x plus equals word width plus space. Okay. Now outside this inner for loop, I'll reassign x. If the line is finished but there is still space, then you need to go to the next line. Okay, that's what a new line means. So I'll reassign x. I'll write x is equals to position 0, and I'll increment y by word height, just what we did when the screen ended. Okay, that was our function, display text function. So inside this while true loop, I'll call on to this function. After screen.fill, I'll write display underscore text. I'll pass in the argument. Screen is the surface I want my text on. I have the message I want to print as text variable, so text would be that message, and I'll start from 20,20, that position. Then I have also declared the font variable, and let the color be purple for the text. Okay, so this was it for this program. Let's run this and see if we get the text in two different lines. So you can see that we have our text in two different lines. So after hello everyone, there is still space, but since I have a new line, so the next line was printed onto a different line. Okay, cool. So we got the text as we wanted it to. Now what if you don't have just two lines but a complete paragraph and you are out of lines? The screen height is completely filled. Here we managed to get the text on a new line when we were out of screen width. But what if we run out of height? You might think of resizing the screen. Think about this, try to write a program to solve this problem. I hope you understood whatever we did in this program. Thank you. Hey everyone, today we're going to discuss making custom user events. Sometimes while making a video game with Pygame, you might need to create a custom event. So we're going to make two user events, one that is initiated by the user and one that works automatically. So I'll have a rectangular object that will inflate to a certain size when I hover over it, and the other event would be the screen changing its color alternatively. Let's write the code for it now. I'll import Pygame. I'll initialize it. I'll set up the screen. Screen equals pygame.display.setMode. The screen size will be 500, 500. And then I'll also give in the caption. I'll write pygame.display.setCaption and let the caption be custom events. Then I'll get to the while true loop. I'll write while true for events in pygame.event.get if events.type equals pygame.quit. I'll call the quit function by Pygame and I will quit. I won't write screen.fill right now. I will do that later. There's a clause to it. I'll get to that later. And then I'll update this. I'll write pygame.display.update. Okay. Now outside this while true loop, let's get to the main code now. Let me define the two user events, two custom events. So let the color changing event be called color. I'll write color equals pygame.userEvent in capital and +1. So that is how you define a custom event. Then I'll have another event, the box crow event. I'll write box underscore crow equals pygame.userEvent +2. So that's the second event. So I've done +2. Okay. Now I'll set up the background color to white to check the next color of the screen, what color needs to be filled next. It will be used later in the color user event when we define it. And I'll have this grow variable of Boolean type to know when the cursor is hovering so that accordingly the rectangle can inflate and deflate. This also would be used in the box grow function. Since I told you I'll be having a rectangle, so let me define it. I'll use the rect class again. I'll write box equals pygame dot rect. Let the initial position be 255 comma 255 and the size be 40 comma 40. Now here I'll be filling in the screen color. Okay, so I'll write screen dot fill and let the color be white initially. So this is like I have just initialized the screen color because in one of my events, that color changing event, I would alternatively change colors of screen. If I put this in the while loop, it would render a single color regularly. Okay, because there is a loop. Okay, then I'll have my clock object to set up the frame rate later. I'll write clock equals pygame.time.clock. Then I'll call on to the color changing function because it would be automatic. So I'll make use of the setTimer method by the time module. I'll write pygame.time.setTimer. The event would be color and comma 500 milliseconds. So that would be the interval. Okay. In what interval I want to call on to this event. Okay. Now in this events loop, I will define these events that I initialized up above. So I'll check if events.time equals color, if background color, this variable, this which was initially white, if bg underscore color equals pink, then I'll fill in the screen with pink color and I'll make bg color equals white. And else if background color is white, I'll fill the screen with white color and I'll reassign background color value. I'll make it pink. So that would help me to alternatively change the colors of the screen. Okay. Then I'll check in for the box grow event. I'll write if events.type equals box underscore grow. I'll check this boolean grow. If it is true, I'll inflate the box in place. We discussed the concept of in place earlier. So I'll write box.inflate in place. Let us inflate it by 4, 4. The x and y coordinates with the same amount, same units. Since I said I would grow the rectangle to a certain size, I would check the box width. If it is less than 80, you can take a larger size. If it is not, I will let grow to be true. Else, if the box is larger than this size, I will make grow false. I won't use a nested if. I would simply write grow equals box.width is less than 80. I'll check if box width is less than 80 and accordingly grow will have that true or false. Okay. Now for the else condition, if grow is false, I'll deflate the box. So there's no such function for deflating, but we can inflate but with negative units. So what I'll write is I'll write box.inflate in place -4 comma -4. So we'll be subtracting this 4 units from the x coordinate and I'll write grow equals box.width is less than 40. Now if the box decreases to a size of 40 or less, grow will become true again. Okay. Now since the box grow event should only be called when I hover over the rectangle, I'll write outside this for loop, I'll write if box.collide point. I can write this for a rectangle class. Pygame.mouse.getPosition in the arguments. This would be checking for the cursor's position. So basically I'm checking if the cursor is over the rectangle. What I'll do is I'll call on to this box grow event. I'll write pygame.event.post. pygame.event.event, and I'll call on to box grow. Okay. After that, I'll draw my rectangle. I'll write pygame.draw.rect, and in arguments, green, orange, let the box color be orange, and box. That was my rectangle. And after this update function, I'll call on to the tick function to set up the frame rate. Let the frame rate be 40. Now let's run this code and see if we could really create some custom events. So the screen changes its color automatically, alternatively, and when I hover over this rectangle, it changes its size as we have defined. It inflates and deflates accordingly. So everything is working fine. We could actually make custom events. So that was it for defining custom events. I hope you understood how we define custom events. Thank you.